Good morning students, welcome to the class. In today's session, in today's video, we are just gonna to discuss that how can we calculate the distance between incenter and the circumcenter. Okay, and this video is just gonna be very important for the students who are just preparing for the SSC examinations and preparing for the examination of the CDS. Okay, and in previous session we just discussed that how can we calculate the distance between centroid and the orthocenter and circumcenter. Okay, we discussed three kind of distances with the help of the Euler line. Okay, but in today's session we are just going to start to discuss that how can we calculate distance between incenter and the circumcenter. Okay, and just to get the derivation of the particular formula which will be helpful in calculating this distance, we have to understand the Euler's geometry theorem. Okay, but before diving into the proof, we are just gonna to discuss the direct formula of calculating the distance between the incenter and the circumcenter. As you know very well, what is incenter? Intersection point of all three interior angle bisectors is known as the incenter. And in the same way, what is a circumcenter? Circumcenter, what is a circumcenter? The point at which the perpendicular bisectors of sides are just gonna to intersect each other, that is the circumcenter. Okay, so we just have to calculate the distance between circumcenter and incenter. Okay, so if in any question you are asked to calculate the distance between circumcenter and incenter, you have to use this formula: d square is equal to capital R square minus 2 capital R multiply small r. Okay, this is the particular formula: d square equal to r square minus 2r into r. Capital R, d is representing to the distance between incenter and the circumcenter. Capital R is representing the length of the circumradius. Okay, you know very well what is a circumradius. Circumradius is the radius of circumcircle. Circumcircle is a circle which just passing through touching all the vertices of the triangle. Okay, and small r is the Inradius. Inradius is the radius of incircle, okay, which is inside the triangle touching all sides of the triangle. Okay, so just to make you understand that how can we use this formula, I'm going to write a question over here. After that we will start discussing the derivation of the formula. Okay, we will discuss that how this particular formula was derivated over here. Okay, so question is that here is a triangle, okay, in triangle ABC, I am saying that angle B equal to 90 degree, and it is said that AB equal to 7 centimeter, BC equal to 24 centimeter, and AC is equal to 25 centimeter. Okay, these are the sides of the triangle. Okay, then we have to find distance between incenter and circumcenter. Distance between incenter and circumcenter, we have to find this circumcenter. Okay, we have to find this. So we have to calculate circumradius and inradius of the triangle. Okay, as here in the question it is directly mentioned that the triangle is the right angle triangle, and you know very well, if we are just gonna to discuss about the right angle triangle, you know very well, in right angle triangle circumradius is always equal to h upon 2. So h is here 25, so you can say it will be 25 upon 2. It will become 25 upon 2. And in radius you can calculate for right angle triangle using this particular formula: p plus b minus h upon 2. Okay, you can use this. And here the perpendicular is perpendicular or base will be 7 and 24, so we can write 7 plus 24 minus 25 upon 2. We can write this. 7 plus 24 is gonna to be equal 31 minus 25, 6 by 2. So in radius is equal to 3. Now we have to calculate the distance between circumcenter and the incenter. We are going to place the values of circumradius and the inradius in this particular formula. Okay, so we can say students, d square will be equal to r square minus 2r into r. So I can say 25 upon 2 square minus 2 into 25 upon 2 into 3. 2 cancelled, so it is 625 upon 4 minus 75. Okay, minus 75. It will be equal to it will be equal to, I can write that this particular number in fraction form. It will be 4 1 ja 4, 4 5 ja 20, 4 6 ja 24, 0.42 ja 8, okay, and minus 75. So we are just gonna to subtract 75 out of this. So answer will be 0.25 651 15 7 8. Okay, so answer is 81.25. Understand that? Now you would have understood that how can we use the particular formula to calculate the distance between circumcenter and the incenter. But this is the formula to use directly in the examination. As we discussed that, we will discuss the proof of the particular formula, that how this particular formula was derived. Okay, and why we are doing these kind of things, just to strengthen our mental ability. Okay, so we can think in a broader way when we are just gonna to see a new kind of the question. So that's the reason to understand the proof of the particular formula. Okay, so I'm just gonna to teach you the particular formula, that how can we calculate, how can we derivate this particular formula, okay, which is applied over here. Now I'm just gonna to discuss a few things. Okay, so suppose this is the circumcircle of a particular triangle, okay, and this is the triangle. So this triangle is just passing through the vertices of the triangle. So this is known as the circumcircle. This is known as the circumcircle. Now I am drawing in circle of the triangle inside this. This is the in circle. Okay, this is the in circle of the triangle. Okay, now as we know very well, okay, I'm saying that this particular line is just passing through the incenter. So I'm saying this is the incenter. Okay, and it is just intersecting to the circle at point L and to the side at point D. Okay, now I'm just going to say that this is the perpendicular bisector of the side of the triangle. Okay, perpendicular bisector of the side of the triangle. Okay, and I'm saying that I'm just assuming that this point is the circumcenter. O is the circumcenter, and this is the I would say this is I. This is I in center. Okay, this is I in center. Understand that? So this particular distance is denoted by point D. Okay, distance between incenter and circumcenter, not orthocenter. Circumcenter is denoted by point D. O is the circumcenter here, and I is the incenter. Okay, now suppose this point is something you can say M. This point is M. Okay, and this is just intersecting to the I would say this is point N. Okay, this is point N. Okay, so as we have discussed in the circle, it is the property of the circle. Suppose this is the circle and there are two chords intersecting to each other at any point. Okay, intersecting to each other at any point. In that case, what can we say? We can say that suppose these are the two chords AB and CD intersecting to each other at point P. So rule says that AP multiply PB, AP multiply PB will be equal to CP multiply DP. Okay, this is the basic property related to the circle. In the same way, we can say that just to prove this, okay, we can say that AI multiply IL. Okay, or we can say that IC multiply IM will be equal to AI multiply IL. Understand that? Okay, now we have to understand one more thing over here, and the thing is that this particular distance, which distance I'm talking about? I'm just talking about OC. OC is the radius of the circumcircle. So this particular portion will be denoted by capital R. This particular portion will be denoted by capital R. Okay, and you can say IC will be equal to R plus D. IC will be equal to R plus D. Definitely we can say that. In the same way, OM is also capital R, and this particular distance is D. So I can say that this particular portion okay, this particular portion, okay, will be r minus d. This will be r minus d. Means I am saying that Im will be equal to r minus d. Why r minus d? Because distance from M to I will be r, okay, and no, sorry, M to O will be capital R. M to O will be capital R. O is the circumcenter, okay, and this is d. So I am just subtracting d. So distance from here to here is r minus d. So I am just placing here IC is r plus d and Im is equal to r minus d, and I am writing AI multiply IL in the same way. I can say using the algebraic identity, we can say that a square minus b square, it will be equal to r square minus d square. It is equal to AI multiply IL. Now we have get d square, we have get r square. Now we need to get 2r into r. Understand that? Now listen me very carefully. Do you know I can say that Inradius, okay, you know what is Inradius? Inradius is just always intersecting the side at 90 degree, okay. So this figure is not drawn properly, little bit, it should be like this, okay, inner circle should be like this. So I would say that this point is N and this particular Inradius will be making 90 degree with the side, okay. Always Inradius will be 90 degree at the side of the triangle, okay. This is small r, this particular line is small r, okay, small r. Now in triangle I can say that I have to just replace to AI. I have to replace to AI, okay. You have to tell me this is angle bisector. Let me correct this in just a minute. I was saying to you, okay, now I'm gonna to tell you, okay. We are just gonna to draw, this is the in circle, okay, this is the in circle. Understand that? I am saying that this is in center and circle is touching the side over here, so this will be in radius and it will be denoted by this capital R, okay. And if AL is angle bisector, so it will be A upon 2. This will be A upon 2. So I can say that you can say here is a triangle, okay, triangle, and this point is N where the perpendicular is just touching this, okay. I am saying IN perpendicular to AB, IN perpendicular to AB, okay. And you can say triangle ANI. Triangle ANI is the right angle triangle, okay. Triangle ANI is 90 degree triangle, okay, right angle triangle. If this is right angle triangle, this is A upon 2, this is A upon 2 and this is R, okay. IN is equal to R, we can say that, okay, and this is A by 2, so this will be hypotenuse, AI will be hypotenuse and this will be equal to perpendicular. So I can say sine A upon 2 will be equal to IN upon AI and IN is equal to R upon AI. So I can say that AI will be equal to R upon sine A by 2, R upon sine A by 2. So this is the result of the AI. We will place it right here, okay. Now we have to calculate IL, we have to calculate IL. You have to tell me that, okay. I'm just gonna to join C and L. I'm gonna to join C and L. Take, okay, I have joined this C and L. Now can you tell me IL will be equal to CL? IL will be equal to CL. Why will be equal to? Okay, why these things are gonna to be equal? I am saying that IL equal to CL. I'm gonna to tell you these things two will be equal. To prove these two equal, we have to prove that this complete angle at C complete should be equal to this angle, okay. So these two are the equal angles. Why equal angles? Actually I'm gonna to tell you very important kind of thing over here. Firstly, tell me this is angle, complete angle C, okay. Complete angle C, this is the angle bisector because it is just passing through the incenter, so this will be C by 2. This will be C by 2. Now tell me here BL is a, what is BL? BL is you can tell me BL is a chord, and BL is just forming a by 2 angle over here. So this angle at C, it will be a by 2. This will also be a by 2. Okay, this will also be a by 2. Understand that? Now you have to tell me one more thing over here. Okay, so I can say that this complete angle is C by 2 plus a by 2. This complete angle is C by 2 plus a by 2. Okay. Now in the same way, this angle at I, it will also be a by 2 plus C by 2. Okay, when these angles are these two angles are equal, it means I can say that IL is equal to CL. IL is equal to CL. These two equal. If IL is equal to CL, I can say that R square minus D square will be equal to AI multiply CL. Okay, this will be the result. Now I have to replace the CL. You can see there is a triangle BLC. Okay, you can see triangle BLC. What is in triangle BLC? One vertex is C, one vertex is L, and one vertex is B. So this same circle, this circumcircle is passing through 3 vertices of the triangle. So this circumcircle will be the circumcircle for triangle BLC also, as well as triangle ABC also. Okay, this is the circumcircle for both the triangles. And if you know the one angle of the triangle, okay, and opposite side also, you can calculate the circumradius. You can calculate the circumradius. Okay, okay, when you know the angle, understand that we can calculate the angle of the particular triangle. Okay, so in the same way, when one side is given, and angle is also given. Okay, one side and angle is given, we can calculate the circumradius of the triangle. Understand that? So circumradius R will be equal to what is the formula when one angle is given? R is equal to A upon 2 sine A. A upon 2 sine A. So R will be equal to CL upon 2 sine A by 2. Because angle is A by 2. So I can say that CL is equal to 2R sine A by 2. 2R sine A by 2. Now I am going to place the values. This is the value of CL. Okay, and this is the value of AI. I am going to place. So it will R upon sine A by 2 multiply 2R sine A by 2 into R. Sine A by 2 cancel. So this is 2R into R. Now we can say D square is equal to R square minus 2R into R. Understand that? So this is the Euler's geometry theorem. I just tried to deliver all the things on a single page so we can relate the things. Understand that? Proof is little bit tough, but proof is just going to improve the mental ability of yours. Direct formula is quite important to do the things. But when we are just going to apply the formula, we are going to learn the things in a better way. Okay, so thank you so much, and keep sharing the things. Okay, thanks a lot. Thank you.